Hi students, good evening all. Welcome to DOPA's live session. Myself Muhammad Anfas, Faculty of Chemistry from Team DOPA. Okay, are you hearing? Okay, so let us start with the chapter. That's the chapter number 3.
Students, good evening all.
Of the plus
DOPA's
1 chemistry,
live session.
that is
Myself Muhammad Anfas, Faculty of Chemistry from Team DOPA.
classification of elements and periodicity in properties. All of you know that this is a part of inorganic chemistry, and this chapter is basically based on the periodic table. Okay, periodic table is the most important concept in the chemistry. So generally most of the people have this is a boring topic, that is inorganic chemistry. So but it is very important for your entrance examination. Okay, so let us start our live session with some summary of this chapter. That is, classification of elements and periodicity in property generally consist of, there are 4 parts. Okay, so the first part is, that is earlier classifications. So in this chapter there are 4 main earlier classifications will be discussed. The first one is Dubrayner classification. We know that Dubrayner classification is proposed by Johann Dubrayner. He classified the elements into small groups, and each group contain 3 elements, that is called as triads, that we already know that. Okay, so an example for triad is lithium, sodium, potassium, calcium, strontium, barium, all are the examples of triad. Okay, so the second classification is, that is Newland's classification. Newland's classification, that is, it is prepared by Newland. He arranged the elements in increasing order of their atomic weight. He noted that the properties of every 8th element starting from a given element having the same property of the first element, just like the resemblance of first and 8th musical note, that is called law of octave, that we already studied, that is Sari, Gama, Pathanisa. Okay, so the third classification is, that is Lothar-Meyer classification, and the fourth one is, that is mental use classification. Okay, this will be you studied in a detail in our chapter. Okay, I will give you a summary of this chapter only. And the second part is, that is modern periodic table, that we know that the modern periodic table contain, there are 18 groups and 7 periods and 118 elements and 4 blocks. Okay, so that is our second part of this chapter, that is modern periodic table. Okay, so the third part is, that is nomenclature of elements with an atomic number greater than 100. That is, in this topic we will discuss how to nomenclature an element greater than 100. That is 101, 102, 103, etc. Okay, that will be studied in the third part of this chapter. And the fourth part of this chapter, that is the periodic properties of element, that is atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, electronegativity, etc. This is the basic overview of this chapter. I think you will get an idea. That is the more periodic classification of element discussed. There are 4 major topics. The first part is, that is earlier classifications, and the second part is, that is modern periodic table, and the third part is nomenclature of element with atomic number greater than 100, and the fourth part is, that is periodic properties of elements. Okay, for entrance purpose, the most important part of this chapter is, that is periodic properties of elements. Is it clear? Okay, so this is the overview. So I will ask you a question. If you have any doubt in this any topic, I will explain that. Otherwise we are moving to the problems. Are you okay? Is it clear? So if you have any doubt in this any topic, we will explain that topic. Otherwise we are moving to the problems. Is it clear? So the first part is, that is earlier classification. There are 4 major earlier classification. The first one is Dubrayner classification, Newland's classification, Lothar-Meyer classification, and mental use classification. Are you okay? So let's check with your notebook. And the second part is, that is modern periodic table. In this topic we will discuss about the groups, periods, blocks, and etc. Okay, so I think all of you know the periodic table very well. That is, the modern periodic table contains, there are 118 elements. First of all, you study the periodic table very well. The first element to 118, you study all the elements very well. Okay, so the first group, second group, third, etc. up to 18 group, you study all the elements. Okay, so the third part, that is nomenclature of element with the atomic number greater than 100. This is also very important. And the fourth one is, that is periodic properties of elements. Okay. If you have any doubt, you can ask question. Otherwise, we are moving to problems. I think you have any doubts, you can ask. Otherwise, we are moving to the problems of this chapter. Okay. Okay, so let's start with our problems. So first of all, we are moving to the problems from the topic, that is earlier classifications. Okay, that is, let us start with the earlier classifications. So the first question, I am giving the question and you can write the answer in your comment box. So I am giving the first question here. This is the first question, that is, which of the following set obeys Newland's octave rule? This is our question. Okay, so I am asking the question, which of the following set of element obeys Newland's octave rule? Okay, here there are four options are there: sodium, potassium, rubidium, fluorine, chlorine, bromine, beryllium, magnesium, calcium, boron, aluminium and gallium. Okay, you can write the answer in your comment box. So what is the option? Okay, lot of people are putting the answer. I am giving the answer here. So what is Newland's octave rule? What is Newland's octave rule? That is, Newland classification says that he arranged the elements in the increasing order of their atomic weight. Is it clear? He arranged the elements in the increasing order of their atomic weight. Okay, yes. So the second point is that he arranged the elements in the increasing order of atomic weight. He noted that the property of the eighth element, starting from the given element, having the same property of the first element. Is it clear? That is, he put the first element, that is lithium here, then they put beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine. Okay, first, second, third, fourth, fifth, sixth and seventh, and they get eighth element, and that eighth element has the same property of the first element. So they put the below the first element. Is it clear? Yes. Here magnesium, here aluminium, silicon, phosphorus, sulfur, chlorine, here potassium, here calcium. Okay, this is the periodic table of Newland's classification. Okay, that is, he noted that the property of the eighth element, 1, 2, 3, 4, 5, 6, 7 and 8, and this eighth element have the same property of the first element, just like the resemblance of the musical note. We know that the musical note, that is sa, ri, ga, ma, pa, da, ni, sa. Okay, yes. So this is called law of octaves. That law is called law of octaves. Is it clear? Yes. So in our question asked that which of the following set obeys Newland's octave rule? So this is the first set, that is lithium, sodium, potassium, and beryllium, magnesium, calcium is the another set. Lithium, sodium, potassium. Any option? There is no option. And beryllium, magnesium, calcium, any option? Beryllium, magnesium, calcium. So option 3 is the right answer. Okay, how many of you get the answer? This is the first question. The answer is beryllium, magnesium, calcium. Is it clear? This is the first question and the answer is option C is the right answer. Okay, that is, a lot of people get the answer. That is Mashuda, Shamna, Biji, Fatima Bashir, Sukrada. A lot of people get the answer. That is, the answer is, that is option 3, that is beryllium, magnesium, calcium. Is it clear? It's very simple. Yes, this is our first question. Okay. Yes. Next we are moving to the second problem. Next we are moving to the second question. What is the second question here? That is, elements which occupied positions in the Lothar-Meyer curve on the peak were. That is, this question is based on Lothar-Meyer classification. Okay, this question is based on Lothar-Meyer classification. And the question is asked that on the peak of the graph, which of the element is present? Here options are given. The option A is alkali metal, option B is highly electropositive element, option 3 element having large atomic volume, and option D all of this. Which is answer is correct? You can put your answer in comment box. The option, this question is based on the Lothar-Meyer classification. Then the question is that on the peak of the curve, which of the element is present? Options are given: alkali metal, highly electropositive element, element having large atomic volume, and all of this. Here so many of the people put the answer option 1 and option 4. The right answer is, that is option 4 is the right answer. That is, here I will give the answer, that is Lothar-Meyer classification is a curve which is based on atomic volume. It is based on atomic volume and atomic weight. A curve which is based on atomic weight and atomic volume. Atomic weight and atomic volume. Okay, that is Lothar-Meyer curve is a curve which is based on a graph between atomic weight and atomic volume. The graph is like this. Okay, in this graph, the crust will occupy, that is lithium, sodium, potassium, etc. That is, in the crust, alkali metals are present. In the crust, the alkali metals are present. But in the trough, the transition elements are present. In the ascending top, the halogens are present. In the descending top, alkaline earth metals are present. This graph is called Lothar-Meyer classification. Is it clear? So, in the question, on the peak of the curve, which of the element is present? That is lithium, sodium, potassium. That is a alkali metal. Okay. So, option A is the right answer. We know that alkali metals are highly electropositive elements because they contain only one electron in their valence shell, so they lose electron, so they are electropositive elements. That also correct. Elements having large atomic volume because they have large atomic volume. This also correct. So the option is option 4 is the right answer. Are you okay? Are you okay? So the right answer is option 4. If you have any doubt, you can ask the question in your comment box. This is our question number 2. That is element which occupy the position in the Lothar-Meyer curve on the peak is, that is alkali metal. You study on the crust, alkali metal, on the trough, transition element, ascending top, halogens, and the descending top, and alkaline earth metals. That's the right answer. Okay? Yes, this is our second question. Are you ready? Okay. Next we are moving to the third question. This is our third question. What is the third question? Which are the correct match? Which are the correct match? Eka silicon is beryllium, Eka aluminium is gallium, Eka mangan is technetium, and Eka scandium is boron. Which of the following are correct answers? Which of the following are the correct answers? Okay. Which of the following is the correct answer? Eka silicon is beryllium? No. That is germanium is Eka silicon. Eka aluminium is gallium, that is correct answer. Eka mangan is technetium, that also correct answer. Eka scandium is boron, no. Eka boron is scandium. So these two are wrong and these two are right answer. So 2 and 3 are the right answer, hence option 1 is the right answer. Is it clear? Is it clear? Yes. This is our question number 3. If you have any doubt, you can ask. Eka silicon is barium is not. Eka silicon is germanium. Eka aluminium is gallium, that is the right answer. Eka mangan is technetium. Eka boron is scandium. So these two are wrong. These two are right answer. So 2 and 3, that is come under option 1. That is the right answer. Is it clear? If you have any doubt, you can ask in the comment box. Yes, I think all of you get the answer. Are you ready? Yes. This is our question number 3. Classification is a very simple chapter if you study this chapter very well. Most of the people say a very difficult part is the part number 4, that is periodic properties of elements. Okay, so we are moving to that part also. Next is question number 4. Okay, the given atomic numbers are given. Atomic number 15, 33, 51 represent which of the following family? You can put the answer in comment box. Carbon family, nitrogen family, oxygen family, and none of this. Okay, what is the answer? 15, 33, 51 represent which of the following family? Carbon family, nitrogen family, oxygen family, etc. And none of this. What is the answer? Yes, Yes, the answer is, that is 15 is nitrogen. Atomic number 15 is nitrogen, hence this family is nitrogen family. Okay, so a lot of the people get the answer. Okay, you all are good. Yes, sorry. So the option is nitrogen family. Okay, is it clear? Now we are moved to the fifth question. That is the fifth question here. That is, which of the following element never has an oxidation state of +1? This is a previous entrance question. Never has an oxidation state of +1. Never have oxidation state of +1. Fluorine is the chlorine, bromine and iodine. Okay, which of the following has never have an oxidation state of +1? Never show +1 oxidation state. What is that element? That is, you can put your answers. Yes, the answer is fluorine. Answer is fluorine. Answer is fluorine. So the option is, option A is the right answer. Are you okay? This is all a very simple question. That means the first, second and third part of the this chapter is very simple, and the most important part is the part number 4, that is periodic properties. Okay. So next question, that is our question number 6 here. Question number 6 here. That is, which of the following represent the electronic configuration of the most electropositive element? Most electropositive elements are the alkali metals are the most electropositive element. From the top to bottom, the electropositivity will be increases. So the first group element in the bottom, that will be the most electropositive. You can put your answers. Option 1, option 2, option 3 and option 4, which is the most electropositive element. Which is the most electropositive element? Yes, we know that alkali metals are lithium, sodium, potassium, rubidium, cesium and francium are the alkali metals, and alkali metals are the most electropositive elements. From the top to bottom, the electropositivity also increases. So in the bottom part, that is the most electropositive element. So what is the answer here? Helium 2s1. No, helium 6s1, helium 2s2, helium 6s2. So xenon 6s1, that is a cesium, electronic configuration of cesium, and cesium is the most electropositive element. So option 2 is the right answer. Are you okay? Yes. Yes, this is our 6th question. Okay, this is a very simple question. Next we are moving to another question, and this is a previous AIPMT question. This is a question from the previous question paper. That is, which one of the following ion has an electronic configuration of argon 3d6? Here the atomic numbers of manganese is given 25, iron is 26, cobalt 27, nickel 28. You can put your answers. That is, the question is that electronic configuration of argon 3d6. Argon 3d6. Yes, argon 3d6. How many of you get the answer? Argon 3d6. Argon 3d6. Argon, we know that argon is 18. Okay, 3d6 means there are 6 electrons. So 6 plus 18 plus 6, that is 24. So we want 24. We know that cobalt is 27. So 3 electrons are lost. So it will be 24. Are you okay? So the right answer is cobalt 3 plus. Simple. I think you will get an idea. So a lot of people are putting the option number 4 here. So right answer is option 1. Why? Because argon is 18. 3d6 means there are 6 electrons. So 6 plus 18, that is 24 here. So 24 is, cobalt is 27. Losing 3 electrons, they get 24. So the right option is option 1 is the right answer. Are you okay? Yes. So if you have any doubt, you can ask in your comment box. I think no one has a doubt. Yes. Are you okay? Yes. So if you have more explanation required, you can use the DOPA application. That is a chapter number 3 classification, and that chapter the SAR will discuss the chapters very well. So you can use the. Okay. So next we are moving to another question, that is the question number electronic configuration of element X. Electronic configuration of element X has an atomic number of 24. 24. What is 24? 24 is, that is scandium, titanium, vanadium, chromium. Chromium is 24. So what is the electronic configuration? Is it clear? You can put your answers. For what is the electronic configuration of chromium? That is Argon 4s1 3d5, because it is a half-filled configuration. 4s2 3d4, putting the one electron to this 3d, so this will be half-filled. So the chromium has Argon 4s1 3d5. So what is the option here? Option 1? Yes, option 1 is the right answer. Are you okay? Is it clear? Yes. Mazroor Ahmad VP put the option number 4. That is wrong, man. The answer 1 is the right answer. Okay. If you have any doubt, you can ask in your comment box. I think no one has a doubt. Yes. So now we are moving to the next question, that is the electronic configuration of neon. This is another question. These all questions are previous entrance questions. So I am putting the questions from the previous question papers. Okay. So what is the atomic number of neon? Neon is 10. So electronic configuration is 1s2, 2s2, 2p6. So check in which option is correct. So what is the option? Yes, that is option 3 is the answer. Okay. So a lot of people get the answer, that is option 3. So you write the answer first and the DOPA will give you a surprise gift. Okay. Yes. So option 3 is the right answer. Yes. So these are the first part questions. Next we are moving to modern periodic table. Before entering to the second part, if you have any doubt regarding this topic, you can ask. Otherwise we are moving to the second part of this chapter. Okay. So for entrance, you can refer the DOPA application thoroughly, so you will get the entrance in your first chance. Okay, so read and use the DOPA application very well. Okay. Yes. If you have any doubt, you can ask. Otherwise, we are moving to the second part, that is the modern periodic table. Are you ready? Yes, modern periodic table. This is the question. An element with the atomic number 21 is dash. What is atomic number 21? That is 21 is scandium. For this, I am telling that the periodic table is a most important one. You study the group 1 element, group 2, group 13, 14, 15, 16, 17, 18 and all the group element. It is very important. Okay. So what is the first group element? Lithium, sodium, potassium, rubidium, cesium, francium. Second group is beryllium, magnesium, calcium, strontium, barium, radium. 13th group is boron, aluminium, gallium, yttrium, thallium. And the 14th carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, and oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, and statin. That is, periodic table is very important to study the inorganic chemistry. So you study the periodic table very well, because after the classification we have a chapter that is hydrogen, and that chapter we will discuss about the hydrogen very well. After that there is a chapter that is S block. In this chapter we will discuss group 1 and group 2. Then there is a P block in the first year chemistry. We will discuss group 13 and 14. And the second year chemistry, there is 15, 16, 17 and 18th group we will discuss. And after that in a +2 there is a D and F block also there. So in our first year and second year chemistry we will discuss the periodic table very well. So first of all you study the periodic table and the 118 elements. Okay. So will I ask you a surprise question? What is the name of an element with atomic number 118? You can put your answer in comment box. Who put the answer first, the DOPA will give you a surprise. The name of the element with atomic number 118. 118. What is the name of 118? Okay. Who put the answer first in the comment box, they got the surprise gift from the DOPA team. Yes, Rina Rahim put the answer first, and Rina Rahim got the answer. That is, the answer is the Rina Rahim Fatima Haifa put the answer. That is Okkanasan is the answer. Okay, so Fatima Haifa and Rina Rahim got the surprise gift. Okay, so the 118 element is Okkanasan. So you study the periodic table very well. Okay. So the 21 is scantium. We know that scantium is a transition element. So the options are halogen, representative element, transition element, and alkali metal. What is the right answer? That is, the answer is transition elements. Are you okay? Is it clear? That is, the option C is the right answer. Yes. Okay. So we are moving to the next question. That is the general electronic configuration of the transition element. What is the electronic configuration of D block element? That is the question. What is the electronic configuration of D block element? That we already studied in the chapter, that is N-1 D 1 to 10 and NS 1 to 2. This is the electronic configuration. Okay. So what is the option? N-1 D 1 to 10. There is a slash is here. That is N-1 D 1 to 10. Okay. So NS 1 to 2. So what is the option here? Option D is the right answer. Option D. That is N-1 D 1 to 10. 1 to 10. Not 1, 1, 10. Okay. Is it clear? So option D is the right answer. Okay. So many of the people put the option B, C, etc. That is not correct. The option D is the right answer. Okay. Yes, this is the transition elements, the electronic configuration of transition elements. So the next question, that is in the periodic table, the metal used as catalyst. Okay, which metal is used as a catalyst? These all questions are previous entrance questions. Okay, which block elements are used as catalyst? Yes, the answer is transition elements are used as catalyst. The reason is that they have a variable oxidation state. Okay, this will be studied in a D block elements also. Okay, so option B is the right answer. Yes. Okay. So next we are moving to the next question. Which of the following electronic configuration represent noble gas? Electronic configuration of noble gas. Noble gas is, that is 18th group. That means they have 8 electrons in their valence shell. So what is the option? A, B, C, D. Which of the following is the right answer? Noble gas is 18th group. So in the valence shell there are 8 electrons are there. So what is the electronic configuration? 18 means there is NS2, NP6. That is, in P orbital there are 6 electrons, in S there are 2 electrons. Total 8 electrons are present in the valence shell. Are you okay? So what is the option here? Yes, option 1 is the right answer. Okay? Yes. I think you have no doubts. Yes? Okay. The next is the variable oxidation state and degenerate orbitals are shown by which block of the element? That is variable oxidation state. Variable oxidation state and degenerate orbitals are shown by which block? S block, P block, D block, and all of this. Okay, which block will give the option? That is S block, P block, D block. Yes, that is transition elements show variable oxidation state. That's why we are using as they are catalyst. Okay, so the option D is the right answer. Yes. Next is, which of the atomic number pairs represent the elements of S block? Okay, this is a good question. This is also a previous entrance question. Which of the atomic number pairs represent atomic numbers of S block? So we know that what is alkali metals? Alkali metals are lithium, sodium, potassium, rubidium, cesium, francium. What is the atomic number of lithium? 3, sodium is 11, potassium is 19, then 35, 37, 55 and 87. These are the electronic configuration of alkali metal. So study well. Lithium, sodium, potassium, rubidium, cesium, francium. And alkali earth metals are beryllium, magnesium, calcium, strontium, barium and radium. Add one atomic number. So here 4, here 12, and here 20, and here 38, here 56, and here 88. Okay. Ready? So what is the answer? That is S block elements. S block. 715. Here there is no 7. So that is not the right answer. 512. 5 is not there, and 12 also. 12 is there, but 5 is not there. Option C, 9 and 17. No. Here 3 is there and 12 is there. Okay. So what is the answer? That is option D is the right answer. Yes. So many people got the answer. Okay. So these all are previous entrance question. I think all of you get the answers very well. So study well. So you will get the in the first chance and your entrance. Okay. This is the topic, that is modern periodic table. So regarding this topic, if you have any doubt, you can ask in the comment box. Otherwise, we are moving to the third part of this chapter. Third part. Ready? So before entering to this part, I will show you some book. This is called capsule, and this capsule is prepared by doctors for doctors, and this is a crash material, and this is very helpful for your coming entrance examination. And this book contains the basic theory and the good questions. So you can use this book capsule for your entrance examinations, and it will very helpful for you. Okay. For more information, you can contact with the DOPA team. Yes. Yes. So we are moving to the nomenclature of element with the atomic number greater than 100. So for this, we know that if the digit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For these digits, we use the names as, okay, I think all of you know that. For the digit is 0, if the digit is 0, we use the name that is nil. Okay. If it is 1, then it is un. For 2, it is bi. 3, it is tri. 4, it is quad. Then it is pend. For 6, it is hex. 7, it is sept. Then it is oct, and that is n. These are the names which is used for the nomenclature of element with the atomic number greater than 100. 0 is nil, 1 is un, 2 is bi, 3 is tri, 4 is quad, 5 pent, 6 hex, 7 sept, 8 oct, and 9 n. Okay. So if you want to name an atomic number of 101, so what is 1? That is un. So you put un here. And what is 0? 0 is nil. And what is 1? That is un. After that you add IUM, you will get the IUPAC name. 101 is un, nil, unium. You get the idea? Okay. So I will show you another atomic number. You can put your answer in the comment box. How to name 104? How to name 104? 104. 104. 1 is un, and 0 is nil, and 4 is quad. So it will be unnilcodium. Unnilcodium. Okay. This can be denoted as unnilcod. UNQ as well. Okay. Is good. How to name 107? 1 means un, 0 means nil, and 7 means sept. So the name is unnil septium. This can be denoted as UNS. Okay. Yes. So I will ask you a question. I think you know the general name of 101? 101 is anilanium. So the name is 101 is called as mentalevium. And 102 that is called as nobelium. So I will ask you a question. So who give the answer first, they got a surprise gift. What is the name of 104? 104. The name of 104. 104. Who put the first? They got the answer. 104. No. 104 is. Yes. Amina Rusta put the answer. That is 104 is called as, that is Rutherfordium is the answer. Rutherfordium. Okay. That is Rutherfordium is the answer. And Rutherfordium is an American name, and the Soviet name of 104 is, that is called as Kurchatovium. And this is a previous entrance question too. That is 104 is called as Rutherfordium or Kurchatovium. Yes, okay. So we are moving to the questions here. Yes, this is the first question. What is the first question? That is, what is the name of the element with atomic number 105? 105. What is 105? 101 is mentalevium. 101 is mentalevium. Okay. 102 is nobelium. And 103 is lawrencium. 104 is Rutherfordium. Here the asked question is, that is 105. So what is 105? 105 is, that is dubnium. Okay. So you study the name of the element with the 101 to 108. That is mentalevium, nobelium, lawrencium, Rutherfordium, dubnium, seaborgium, borium, hassium, meitnerium, Darmstadtium, Roentgenium, Copernicium, etc. Okay. So study all the atomic numbers. So I will ask you one more question. What is the atomic number of 117? What is the name of 117? What is the name of 117? Who put the answer first? What is the name of 117? 117. Name of 117. No one put the answer. Who put the answer first? 117. What is the name of 117? I think no one have the answer. Yes, Sukrita Sandosh put the answer. Yes, good. The answer is tennessine. The name of 117 is tennessine. Yes, 118 is oganesson. 117 is tennessine. 116 is livermorium. 115 is moscovium, and this is fluorovium, and this is nihonium. Okay. What is 118? That is oganesson. 117 is tennessine. 116 is livermorium. 115 is moscovium. 114 is fluorovium, and 113 is nihonium. Okay. So study the name of all the elements from 101 to 118. Okay. This is very important for your entrance. Yes. So here the question is, that is 105. Sorry, 105. 105. So 105 is dubnium. So the answer is option B is the right answer. Are you okay? Yes. Next question. What is the atomic number of unhexium? Unhexium. Un means 1. Un means 1. Hex means 6. So what is the answer? That is 116 is the answer. So option 3 is the right answer. Yes. So one more question is that is Rutherfordium is also known as, that we already discussed. The Soviet name of Rutherfordium is what? That is, that we already discussed, that is called as Kurchatovium, and this is a previous entrance question too. Okay, and this is a previous entrance question too, that is Rutherfordium is also known as Kurchatovium. Yes. And one more question is what is the atomic number of unyl septium? Unyl septium. What is the atomic number of unyl septium? What is unyl septium? Okay, you can put your answer in comment box. What is the atomic number of unyl septium? Un means 1. Nil means 0. Septium means sept. Sept is 7. So the option is 107, not 117. Fatima Bashir put the option 117. That is not right. Okay, 107 is the right answer. Okay, so the option 3 is the right answer. Yes. Okay. So these are the questions which is based on the nomenclature of element with atomic number greater than 100. In this topic, you will study the name of elements from 101 to 118. Yes, 101 is mentelium, nobelium, lawrencium, rutherfordium, tupinium, seaborgium, and study these names very well, so you can write the answer simply. Okay, if you have any doubt, you can ask. No one is asking doubts here. I think all of you are expert in this chapter. Okay. Yes. What do you feel about the chapter classification of elements? It is simple or very hard? How many of you are very simple in this chapter? Akshaya Pakiha. Who is that? How many of you feel very good about this chapter? If you have any doubt regarding the nomenclature, you can ask. Otherwise, we are moving to the most important part of this chapter, that is the last part of this chapter, that is periodic properties. Okay. So many people put the answer. It is very simple chapter. It's a very good chapter, easy chapter as well. Okay. So this is a very good chapter if you know the fourth part very well. Otherwise, this chapter become very hard. Okay, so our next part is the most important part. Here I will give you some of the shortcuts. Okay, so that is the fourth part. It is the most important part, that is periodic properties of elements. Periodic properties of elements. Okay, that is, someone asked that, sir, can you discuss equilibrium? Okay, we will discuss a live on equilibrium on another session. Okay, yes, here we will discuss equilibrium on another session. Yes. So next we are moving to the last part of this chapter, that is periodic properties. Here I will give you a level 1, level 2 problems of this periodic properties, and the level 3, level 4, level 5 sessions on another live. Okay. So I think if you have the idea of the theory regarding this topic, then you can put your answer very well. Otherwise, it becomes some tough. Okay. So I am moving to the part here. The periodic properties. In this session, we will discuss the different periodic properties. What is meant by periodic property? First of all, you know that what is periodic property? What is meant by periodic properties? Periodic property is nothing but the properties which repeat after a regular interval is called periodic properties. Okay. Yes. What is meant by periodic properties? Properties which repeat after a regular interval is called periodic properties. In this chapter, we will discuss the periodic properties such as atomic size, that is atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, electronegativity, electropositivity, etc. Okay. If you know the theory very well, then you can put a like on here. Yes. Yes. So we are moving to the problems. I think all of you know the basic theory very well. So we are moving to the problems. Okay. So this is the first question. Okay. This is the most important part, and most of the question from this chapter is coming from the fourth part. So this topic is very important. What is the first question? In which of the following compound manganese shows maximum radius? In which of the following compound manganese shows maximum radius? Okay, so you can put your answers in the comment box. Which of the following compound manganese shows maximum radius? In which option manganese show maximum radius? Option 1, 2, 3 or 4? Here all of the options are there. Option 1 is there, 2 is there, 3 is there, 4 is there. All options are there. Yes? What is the right answer? In which of the following compound manganese show maximum radius? Yes, all options are there. I think most of the options are option 3. Yes, so the right answer is option 3 is the right answer. Why the option 3? So I will give the answer. That is, the radius is inversely proportional to the oxidation state. This is the clue of this topic. That is radius is inversely proportional to oxidation state. That is, when the oxidation state increases, the radius will be decreases. Which of the following option has the minimum oxidation state? That has the maximum radius. So you can find out the oxidation state here. Oxygen has -2, so it will be -4, so it will be +4. Any doubt? Here is -8, it is +1, so -7, so it will be +7. Here -2, so it will be +2. Here +1, so it will be +3, so it will be -3. X minus 6 equal to -3, x is equal to -3 plus 6, that is equal to 3. So here manganese is +3. So in which option, which of the following has minimum oxidation state? Option 3 has minimum oxidation state. That's why the option 3 is the right answer. You got the idea? You got the idea? Yes? The clue is, that is, the radius is inversely proportional to oxidation state. Which of the following has minimum oxidation state? That has the maximum oxidation state. Are you okay? Is it clear? Yes. And the next question. Are you okay? Next we are moving to the next question. The correct order of atomic size of carbon, nitrogen, phosphorus, sulfur follows the order. And this question is a very important question, and this is a previous entrance question. In every entrance question paper, and this like question is coming, and this is a very important. Okay, you can put your answers in comment box. What is the option here? Correct order of atomic size of carbon, nitrogen, phosphorus, sulfur follows the order. Carbon, nitrogen, phosphorus, sulfur. What is the answer? Carbon, nitrogen, phosphorus, sulfur. The order of atomic size, that is the question. Order of atomic size. Okay. What is the option here? Someone put the option 1, option 2, option 3 is there, option 4 is there. Yes? Which option is the right answer? The correct order of atomic size of carbon, nitrogen, phosphorus, sulfur follows the order. This is a very important question, and this is a previous entrance question too. In every entrance question paper, one of the question is like this, the order of increasing order, decreasing order, etc. Okay? Yes. For this, I will give you a graph. Okay? So if you know that graph, then you can easily put the answer. That is, the graph is here. This is the graph. Okay? Here I will give you the graph. We know that this is the 13th group element, this is 14, and this is 15, 16, 17, 18. Okay? So you put the elements here: boron, carbon, nitrogen, oxygen, fluorine, and neon. The second element are boron, after boron, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Here I will am writing the atomic radius in the below, that is boron has 83, 77 and all. Okay, so the order is that the least radius is for neon. If I am taking these two periods, that is the least radius is neon, that's why I am taking the arrow is like this. Least radius is for neon, then fluorine, then oxygen, then nitrogen, then carbon, then boron, then argon, chlorine, sulfur, phosphorus, like this. So you study this one, so you can make the answer here. Here the option carbon, nitrogen, phosphorus, sulfur. Carbon, nitrogen, phosphorus, sulfur. Okay, these are the options. So you can check here. Carbon is here, then nitrogen is here, then phosphorus is here, then sulfur is here. Which of the following has maximum radius? Phosphorus. So phosphorus, then sulfur, then carbon, then nitrogen. This is the right answer. Okay, phosphorus, sulfur, carbon, nitrogen. Phosphorus, sulfur, carbon, nitrogen. So option 1 is the right answer. Okay, you get the idea. If I will show you another question, that is, I will show you another question. If the question is that silicon, phosphorus, nitrogen, oxygen is like this. So what is the order? What is the order here? You can using this you can find the answer. Silicon is here, phosphorus is here, nitrogen is here, oxygen is here. Which of the following has maximum radius? The answer is silicon, then phosphorus, then nitrogen, then oxygen. Are you okay? You get the idea? By using this graph, you can find any question from this topic. There are a lot of questions are coming from this topic. I will show you another question. Aluminium, boron, nitrogen, phosphorus. This is another previous entrance question. So another, what is the order of atomic radius? You can use this. That is, here aluminium is there, then boron is there, then nitrogen is there. Sorry. What is the order? First of all aluminium, then phosphorus, then boron, then nitrogen. This is the order. You get the idea? Yes? Okay, this is the order, and I will show you another order, and this is the another order, that is lithium, beryllium, sodium, magnesium, potassium, calcium, and these elements are coming. You can use this. Okay, the reason for this I will explain in the video. That is lithium, beryllium, sodium, potassium. Okay, so beryllium has 113, lithium has 152 and 160, 186, 197, 215, and you can use this order. Okay, so there is a question is coming like this, that is sodium and calcium, beryllium and atomic radius. You can put directly, that is the which is coming first, that is calcium is coming first. Yes, so calcium has maximum radius. After the calcium the sodium is coming, then first of all radium is coming, then calcium, then sodium, then beryllium. This is the order of atomic radius. Okay, yes, this is a simple idea. By using this graph you can find the atomic radius of any elements. Okay, you get the idea? These are the two boxes. This is the first box. This will be draw in your notebook, so you can find the lot of questions, otherwise you will confuse on this. Okay, okay. Yes, this is the question. So we are moving to the next question here. Okay, next question is, that is the correct order of decreasing ionic radii among the following isoelectronic species. Okay, these all are the isoelectronic species. The correct order of decreasing ionic radii among the following isoelectronic species. Okay, here there are 4 options are there. This is the first option, second option, third option and fourth option. If you have any doubt, you can ask. Which is the correct answer? Which is the right answer? That is the correct decreasing order of ionic radii among the isoelectronic species. Okay. What is the answer? Option 1, 2, 3 or 4? What is the option? Yes, option 4 is the right answer. Why? That is, this is an isoelectronic species. This in the question is given that this is an isoelectronic species. For an isoelectronic species, the anion with the largest negative charge has largest radius. Okay, this is the most important point. Anion with the largest negative charge has largest radius. Yes, anion with the largest negative charge has largest radius, and cation with the largest positive charge have smallest radius. Okay, that's the logic. Okay, this is the important point. That is anion with the largest negative charge have largest radius, and cation with the largest positive charge have smallest radius. Okay, for example, I am taking an example, that is I am taking neon here. The neon is atomic number 10, so the number of electron is 10 electrons. Next is sodium. The atomic number is 11, so I am Na plus. There are 10 electrons. Mg is 12, so Mg2 plus. There are 10 electrons. Aluminium is 13, so Al3 plus has 10 electrons. Okay, so here fluorine, the atomic number is 9, so 9 electrons, so F minus gaining 1 electron, so they have 10 electrons. Oxygen is 8, so O2 minus has 10 electrons. Nitrogen, N3 minus has 10 electrons. All of them has 10 electrons, so they are isoelectronic species. Isoelectronic species. And the main point, that is here anion with the largest, this all are anions, this all are anion. Anion with the largest negative charge have largest radius. So the order of radius is, this is greater than, this is greater than this. Okay. And the next point is, this all are cation. Cation with the largest positive charge have smallest radius, and this has the smallest radius. So the order will be like this. Okay. This is the logic we used in this problem. Are you okay? Yes, I think you will get an idea how to solve this problem. The idea is that is anion with the largest negative charge has largest radius, and cation with the largest positive charge have smallest radius. This is used only for isoelectronic species. Okay. Okay. Yes, I will show you another question. I will put a question here. So who put the answer first? The DOPA will give you a surprise. Okay. So this is also another question. This is a JEE main 2017 question. Okay. I will question, arrange flowing increasing order of size. Arrange the flowing in the increasing order of size. I am putting the option here, that is O2 minus is the option, B is F minus here, C is Na plus here, and D Mg2 plus here. These are the option. O2 minus, F minus, Na plus, and Mg2 plus. That is, which of the following has maximum radius? Okay. These all are isoelectronic species, so you can put the above rules. If it is not a isoelectronic species, so how to do this type problem? That's we are going to explain. Okay. That is, the logic is that, okay, you can put the options, which of the following has maximum size? O2 minus, F minus, Na plus, or Mg2 plus. Yes, option A. So that we know that here, that we already discussed here, that is anion with the O2 minus, F minus, and Na plus, and Mg2 plus, that we already discussed. Anion with the largest negative charge have largest radius, cation with the largest positive charge have smallest radius. The basic idea is that, you first find out the P by E ratio. You find the P by E ratio. Find the P by E ratio. And which of the following has smaller the P by E ratio and which has the largest size? That is, smaller the P by E ratio, larger the size of ion. Okay, this is the main idea. That is, smaller the P by E ratio, larger will be the size of ion. Smaller the P by E ratio, larger will be the size of ion. Okay, so I will show you the idea. That is the first option, that is O2 minus. How to find the P by E ratio? P by E, that is proton, that is how many are proton? 8. What is the number of electron? That is 10. So it will be 0.8. Yes. Next is F minus. F minus, that is P by E ratio is F is 9 and that is 10. So it will be 0.9. Next is Na plus. P by E ratio is Na is, that is 11. So electron is 10. So it will be 1.1. Okay. And next is Mg2 plus. So the P by E ratio is magnesium, that is 12 and electron is 10. So it will be 1.2. So which of the following has smaller the P by E ratio? That has the largest size. So this has smallest value. So the order will be like this. This is the idea to find the order of size. You get the idea? You get the idea? This is the idea. That is, the point is smaller the P by E ratio and larger will be the size of ion. I will show you one more question here. Are you okay? Yes. That is, options are S2 minus here, K plus is here, Ca2 plus is here and Cl minus is here. Which of the following has largest size? Okay, this is also a previous entrance question. Which of the following has largest size? Option A, option B, option C and option D. This is the question. Which of the following has largest size? Okay, this is the question. Which of the following has largest size? Okay, so you can find out the P by E ratio here. That is, P is proton is 16, 16 by 18, so it will be 0.88. Okay, so what is the proton of potassium? That is 19 divided by 18, so it will be 1.05 here. Calcium is 20, losing 2 electrons, so it will be 18, so 20 by 18, that is 1.11 here. Chlorine is 17 by gaining 1 electron, so 17 by 18, so it is approximately 0.9 something. Okay, so which of the following has smallest value? Smallest value is, that is for S2 minus. So S2 minus, then Cl minus, then for K plus, then for Ca2 plus. You get the idea? This is the order. So that is, you find out the P by E value. Which of the following has the smallest P by E value? That is the largest radius. Okay, this is also a previous entrance question. Okay, yes, this is the way to calculate the atomic radius. You get the idea? If you get the idea, you can put a like button on the comment box, so I can understand that you will get the idea. Okay, if you get the idea, you can put a comment, a like on the comment box. Yes. Yes. Okay. Ready. So next we are moving to another question. What is the correct decreasing order of ionic radii of the following ions? That is N3 minus, O2 minus, F minus, Na plus, Mg2. That we already discussed. That is isoelectronic species are there. That is anion with the largest negative charge have largest radius, cation with the largest positive charge have smallest radius. So what is the option? That question that we already discussed. N3 minus, O2 minus, F minus, Na plus and Mg2 plus. So this is the option. Okay. Option B is the right answer. Yes. Are you ready? Okay. So this is the next question. Correct order according to size. What is the option here? O is the, O minus is the, O2 minus is the. We know that anion with the largest negative charge have largest radius. Cation with the largest positive charge have smallest radius. So anion with the largest negative charge is O2 minus, then O minus, then O. What is the option here? That is, what is option? That is option C is the right answer. Yes, this is a very simple question. Okay, this is the next question, and this is also a previous entrance question. IP1 and IP2 of Mg are 178 and 348 kilocalorie per mole. The enthalpy required for the reaction Mg gives Mg2 plus 2 electron. Okay, you can find the answer and put the options in your comment box. Who put the answer first? Okay, this is the question. This is a very good question, and this is a previous entrance question too. Okay, what is the answer here? Here the question is that IP1 and IP2 of Mg are 178 and 348. We want to calculate Mg gives Mg2 plus 2 electron. Yes, a lot of people is putting the option 2 and some of the people is putting the option 3 here. So what is the option here? Okay, we can do our problem. What is mean by IP1? IP1 is the ionization, first ionization energy. First ionization energy means Mg gives Mg plus 1 electron. Okay, that is the first electron losing, that is first ionization energy, that is given, that is IE1, that is 178. Okay, yes. Next is IP2 means losing one more electron, so Mg plus gives Mg2 plus 1 electron, and that is given as, that is IE2 348. In the question is asked that to calculate Mg gives Mg2 plus 2 electron. We want to calculate how to make this equation from this two equation. I am adding this two equation. So what will happen? This Mg plus and Mg plus will be cancelled. So Mg gives Mg2 plus 1 2 electron. So adding this two, IE is equal to IE1 plus IE2. That is 178 plus 348, that is plus 526 is the right answer. Okay, plus 526 is the right answer. You get the idea? So what is the option here? That is option 2 is the right answer. Simple? Yes, this is the question, and this is a previous entrance question too. Okay. Next is the order of first ionization enthalpies of lithium, beryllium, boron, sodium. Okay, this is the question, that is first ionization enthalpies of lithium, beryllium, boron, sodium. Lithium, beryllium, boron, sodium. Lithium, beryllium, boron, sodium. This is a question which is based on the topic, that is ionization energy. Okay, this is the question, and this is also a very important question. This question is also important. And the question is asked that the order of first ionization enthalpies of the elements lithium, beryllium, boron and sodium. Okay, for this I will give you that this is a order will be given here. That is second period, we know that from the left to right the size will be decreases, so ionization energy will be increases. So there is exception will be the ionization energy of beryllium is greater than boron due to the completely filled orbital in the beryllium, and also the first ionization energy of nitrogen is greater than oxygen due to the half filled p orbital in the nitrogen. So this is the order: lithium, boron, beryllium, carbon, oxygen, nitrogen, fluorine, neon. The only difference is that here there is a difference and here there is a difference, because beryllium greater than boron because due to half filled due to completely filled s orbital, here there is a half filled p orbital, and this is the order of third period. Are you okay? Are you okay? This is the question. So in this question, that lithium, beryllium, boron, sodium, lithium, beryllium, boron, sodium. So which of the, here beryllium is there, boron is there, and lithium is there, sodium is there. We know that from left to right ionization increases, so the maximum has beryllium, then boron, then lithium, then sodium. This is the answer. Okay. Yes, first beryllium, then boron, then lithium, then sodium. Because size increases, ionization decreases. So what is option? Sodium, lithium, boron, beryllium. So option 2 is the right answer. Are you okay? Is it clear? You get the idea how to do this problem? Yes? Okay, this is option 2 is the right answer. So study this order very well. Study this order, and this is very important. By studying this order, you can easily solve the problem. If any of the elements are given, you can, using this order, you can find the answer. Okay? Yes. The next question is that the correct decreasing order of first ionization enthalpies of 5 elements in the second period: beryllium, boron, carbon, nitrogen, fluorine. Beryllium, boron, carbon, nitrogen, fluorine. Beryllium, boron, carbon, nitrogen, fluorine. What is the order? Fluorine here, then nitrogen here, then carbon here, then beryllium here, then boron. This is the right answer. Simple. By using this box, you can find the order very well. Yes. So boron, beryllium, carbon. So option C is the right answer. Okay. Are you okay, students? If you have any doubt, you can ask. It is very simple. If you know these orders, then you can find the answer very well. Simple. If are you okay, then you can put a like button on the comment box. Then we are moving to the next questions. Okay. If you have any doubt, you can ask. Otherwise, you can put a like button on the comment box, so I can understand that you will get the idea of these topics. This is the next question, that is the correct ionization of carbon, nitrogen, oxygen, fluorine. Carbon, nitrogen, oxygen, fluorine. What is the order? Carbon here, nitrogen here, oxygen here, fluorine, which has carbon, oxygen, nitrogen, fluorine. Carbon, oxygen, nitrogen, fluorine. So what is the order? Carbon, oxygen, nitrogen, fluorine. So this is the option. Simple. That is, if you know that box very well, then you can understand you can do the problem from that topic. Okay? Yes. Next we are moving to another topic, that is, which of the following oxide is most acidic oxide? Most acidic oxide. Okay, this is a very good question. This is a very important topic, that is acidic nature. Acidic nature. Okay, how many of you know that this topic is very well? How many of you know this topic very well? That is, in every entrance question paper, the question is asked that which of the following has maximum acidity, which of the following has lesser acidity, which of the following has maximum basicity, which of the following is amphoteric, the order of amphotericity, order of basicity, order of acidity, decreasing order, increasing order, etc. This is a most important topic from the inorganic chemistry. I think most of the people have a very difficult concept regarding the acidity, basicity, and amphotericity. Okay, if you know the idea very well, so you can put your answers here. Which of the following oxide is most acidic? Which of the following is most acidic one? Which of the following is most acidic one? Yes. So some of the people is putting the option A here. Yes. Okay. So I will explain this very well because this is a very important topic. So which of the following is the most acidic oxide? That is our question. Here the options are BeO, MgO, CaO and BaO. Okay, this is a very good question because really the answer is BeO. Okay, but BeO is an amphoteric oxide and these three are basic oxides. Okay, so if you are mug-upping this topic, you cannot answer this type question. So I will give you a box here, and this is a very important. If you study this topic and this box, then you can find out the question from this topic. Are you okay? Yes. So a lot of people are asking that, can you explain? Yes, I will explain it. Okay. Yes. Okay, so you can draw my box. I will drawing a box here. Okay, this is a very important one. This is a very important one. Yes. Okay, so this is the first group, and this is the second group, and this is 13th group, and this is 14th group, this is 15th group, this is 16th group, and this is 17th group. Okay, here I am drawing a graph here, a box here. If you know this box very well, so you can understand any question from the acidity, basicity and amphotericity. Okay, that is here I am plotting first, second, 13, 14, 15, 16 and 17. Okay, if you are drawing this box by using, there are three colors. Okay, by using color I will explain the acidity, basicity and amphotericity. Are you okay? Yes. For this I am taking, there are three colors here. So one is black and one is red and one is green. Yes. Okay. The first one is black. The first one is, that is lithium. Here I am putting lithium. Okay, by using color I will explain. So first of all I am writing the elements, after that I will explain. Lithium, then sodium, potassium, then rubidium, then cesium. Okay, yes, then magnesium, calcium, strontium, barium. Okay, lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, strontium, barium, and these oxides are basic oxides. Yes, and these all are basic oxides. And here the last elements, that is fluorine, chlorine, bromine, iodine and astatine. And here oxygen, sulfur, selenium, tellurium, polonium, and here nitrogen, phosphorus, here carbon, silicon and boron, and all these green elements are acidic oxides. Okay, that is, these black elements are basic oxides and these green elements making acidic oxides, and blue here I am taking here beryllium, and here this is aluminium, and this is gallium, and this is indium, silicon, germanium, then tin, then lead, arsenic, antimony, bismuth, and this all are amphoteric oxides. And I am adding one more thing, that is zinc oxide is also an amphoteric oxide. This is our the box. Okay, if you know this box very well, then you can find the acidity, basicity and amphotericity. I will explain it. Okay, so here I am using, there are three colors, black color, blue color and green color. The black colored using elements lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, strontium and barium making basic oxide. Okay, is it clear? lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, strontium, barium forming basic oxides. Okay, study well. And these green elements, fluorine, chlorine, bromine, iodine, astatine, oxygen, sulfur, selenium, tellurium, polonium, nitrogen, phosphorus, and carbon, silicon, and boron. This all green elements making acidic oxides. And this blue element, beryllium, aluminium, gallium, indium, germanium, tin, lead, arsenic, antimony, bismuth, all are making amphoteric oxide, and also ZnO making amphoteric oxide. If you know this box, then you can find the acidity, basicity, or amphotericity. I will show you one question that if there are three elements are the sodium and aluminium, then silicon and phosphorus, which is making basic oxide, you can directly put the answer from this box because sodium is a forming basic oxide. Simple. Simple. You get the idea? Yes. I will show you another question that is arsenic, selenium, bromine, tellurium. Okay, that is arsenic here, selenium here, bromine here, tellurium, which is forming amphoteric oxide, arsenic forming amphoteric oxide. You can directly put the answer. This is the way. Yes, this is the simple type of question which is coming from this topic. And the next level is we know that lithium, sodium, potassium, rubidium, cesium, and this all are making basic oxide. So in which is forming more basic oxide. So for this I will give you an idea, that is electropositivity increases, basicity also increases. This is the point. I think you will get an idea. The logic is electropositivity increases, basicity increases. Electropositivity increases, basicity increases, and electronegativity increases, acidity will be increases. Okay, these are the two logics. Electropositivity increases, acidity increases, electronegativity increases, electropositivity increases, basicity increases, electronegativity increases, acidity increases. Are you okay? Are you okay? So what is electropositivity? We know that from left to right, that is from right to left, the electropositivity will be increases. That is lithium or beryllium, which is more electropositive, lithium, beryllium or carbon, which is more electropositive, beryllium. That is from right to left, electropositivity increases, and also from top to bottom, electropositivity also increases. You got the idea? That is when electropositivity increases, basicity also increases. So I will ask you a question, that is potassium oxide or rubidium oxide is which is more basic? Rubidium oxide. Rubidium oxide or cesium oxide is more basic? Cesium oxide. Are you okay? You got the idea? Yes. That is when electropositivity increases, basicity increases, and electronegativity increases, acidity also increases. This is the idea. Are you okay? Yes. So in our question, okay, our time is over. Yes, this wind upping session, so our color will be changed. That is, we know that our question is, I am doing this question, there is beryllium oxide, magnesium oxide, CaO and BU are of the option. So beryllium oxide is here, and magnesium oxide is here, and CaO is here, and BaO is here. Which of the following is a most acidic oxide? Okay, we know that all this beryllium is a amphoteric oxide and all these are basic oxide. But the electropositivity is increases, the basicity will be increases. So the barium is more electropositive. So barium is more basic. So beryllium is less basic. So it will be more acidic. So the option BeO is the right answer. Okay, you got the idea? Yes. I think you will get an idea how to solve this. I will show you one more question. That is an oxide of an element whose electronic configuration is 1s2, 2s2, 2p6, 3s1. So 2, 2, 6, 1. That is atomic number is 11. 11 is sodium. So sodium making which of the following oxide? That is sodium forming basic oxide. So the option, that is option C is the right answer. Are you okay? You get the idea? By using this box, you can find out any of the answer. Here some problem is here, so all of them become black color. Okay, I will show you one more question, that is which of the following is most basic oxide? ZnO is here, Al2O3 is here, As2O3 is, K2O is here. We know that potassium is a basic oxide, so the option is, that is option, this is the answer. Okay, our time is over. So I think you will get an idea how to solve the problems from the chapter Classification of Elements and Periodicity in Properties. Here we discuss some of the questions from this chapter. So there are a lot of shortcuts are remaining in this chapter. So there are remaining our live sessions. We will discuss other shortcuts too. So this is our live session. I am wind upping our live session. So I am one more time I will explaining that. Okay, I think all of you are Keralites, so I am speaking in Malayalam in the last time. Okay, അപ്പോൾ ഇതുവരെ എടുത്ത കാര്യങ്ങളൊക്കെ എല്ലാവർക്കും മനസ്സിലായിട്ടുണ്ടാകും എന്ന് തന്നെ വിചാരിക്കുകയാണ്. നമ്മുടെ ക്ലാസിഫിക്കേഷൻ ഓഫ് എലമെൻറ്റ്സ് ആൻഡ് പീരിയോഡിസിറ്റി ഇൻ പ്രോപ്പർട്ടീസ് എന്ന് പറയുന്ന ചാപ്റ്ററിനകത്ത് ഒരുപാട് ഷോർട്ട് കട്ടുകൾ നമുക്ക് ഉപയോഗിക്കാൻ പറ്റുന്ന ഒരു ചാപ്റ്ററാണ് ക്ലാസിഫിക്കേഷൻ. അതിൻ്റെ അവസാനത്തെ ഭാഗമായിട്ടുള്ള പീരിയോഡിക് പ്രോപ്പർട്ടീസാണ് എൻട്രൻസിലേക്ക് വരുമ്പോൾ ഏറ്റവും പ്രധാനമായിട്ട് വരുന്നത്. അതിൽ അസിഡിറ്റി ഞാനിപ്പോൾ അവസാനം കാണിച്ച ഭാഗമൊക്കെ എൻട്രൻസിന് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. നമ്മുടെ സമയം കഴിയുന്നതുകൊണ്ട് നമ്മൾ തൽക്കാലം അവസാനിപ്പിക്കുകയാണ്. അതിനകത്ത് ഒരൊറ്റ കാര്യം കൂടി നമ്മൾ ഓർമ്മപ്പെടുത്തുകയാണ്, അതായത് ഡോപ്പ നിങ്ങൾക്ക് വേണ്ടി നൽകുന്ന ഒരു ക്യാപ്സ്യൂളുണ്ട്. ഈ ക്യാപ്സ്യൂൾ എന്ന് പറഞ്ഞാൽ എൻട്രൻസിന് വേണ്ടി മാത്രം ഇവിടെയുള്ള ഡോക്ടേഴ്സ് നിങ്ങൾക്ക് വേണ്ടി പ്രിപ്പയർ ചെയ്ത മെറ്റീരിയലാണ്. ഇതിനകത്ത് ഓരോ ചാപ്റ്ററുകൾക്കകത്തും വളരെ സെലക്റ്റീവായിട്ടുള്ള ചോദ്യങ്ങളുണ്ട്. ആ ചോദ്യങ്ങൾ കൃത്യമായിട്ട് അത് വീഡിയോയിലൂടെ എക്സ്പ്ലെയിൻ ചെയ്യുകയും അതാത് സമയത്ത് തന്നെ നിങ്ങൾക്കത് എഴുതിയെടുക്കാൻ കൂടിയുള്ള അവസരങ്ങളുണ്ട്. അപ്പം അത് ഡോപ്പയിൽ ഓൾറെഡി ജോയിൻ ചെയ്ത വിദ്യാർത്ഥികൾക്ക് ഇത് ഫ്രീ ആയിട്ടുണ്ട്. ബാക്കിയുള്ള ആളുകൾക്ക് ഇത് പർച്ചേസ് ചെയ്യാവുന്നതാണ്. അപ്പം ഡോപ്പ ആപ്ലിക്കേഷൻ നിങ്ങൾ നന്നായിട്ട് ഉപയോഗപ്പെടുത്തുക. ഞാൻ വേണമെങ്കിൽ ഇതിൻ്റെ 1-2 പേജുകൾ നിങ്ങൾക്ക് കാണിച്ചു തരാം. ഇതിൻ്റെ പുതാകരത്തിന് സം ബേസിക് കോൺസെപ്റ്റ് എന്ന് പറയുന്ന ചാപ്റ്റർ എടുത്തു കഴിഞ്ഞാൽ അതിനകത്ത് ആദ്യം ടീച്ചേഴ്സ് നിങ്ങൾക്ക് അതിൻ്റെ തിയറി എക്സ്പ്ലെയിൻ ചെയ്യുന്നുണ്ടാവും. അതിൻ്റെ തിയറി എക്സ്പ്ലെയിൻ ചെയ്യുന്നതിൻ്റെ സ്ഥലമാണിത്. പിന്നെ അതിനകത്ത് ഓരോ ചോദ്യങ്ങളുണ്ടാവും, അത് എഴുതാനുള്ള സ്പേസുകൾ അതിൻ്റെ കൂടെ തന്നെ ഉണ്ടാവും. ടീച്ചർ എക്സ്പ്ലെയിൻ ചെയ്യുന്ന സമയത്ത് നിങ്ങളുടെ കൈവശമുള്ള പുസ്തകം വെച്ച് തന്നെ നിങ്ങൾക്ക് അതിൻ്റെ ഉത്തരങ്ങൾ അവിടെ എഴുതിയെടുക്കാനുള്ള അവസരം കൂടി ഉണ്ടാവും. അപ്പോൾ ഒരു ക്രാഷ് പ്രോഗ്രാമിൽ ഇതുവരെ നിങ്ങൾ കണ്ടിട്ടില്ലാത്ത ഒരു പുതിയൊരു ക്രാഷ് പ്രോഗ്രാമിൻ്റെ രീതിയാണ് ഡോപ്പ നിങ്ങൾക്ക് വേണ്ടി സമർപ്പിക്കുന്നത്. അത് കൃത്യമായിട്ട് ഉപയോഗപ്പെടുത്തുക. എൻട്രൻസ് അത് ആദ്യത്തെ ചാൻസിൽ നിങ്ങൾക്ക് എത്തിക്കാൻ വേണ്ടിയാണ് ഡോപ്പ ഇതുപോലെയുള്ള പുതിയ പല പ്രോഗ്രാംസുകളും നിങ്ങൾക്ക് വേണ്ടി നൽകുന്നത്. അപ്പോൾ കൃത്യമായിട്ടും ഇത് നിങ്ങൾ ഉപയോഗപ്പെടുത്തുക. അപ്പം എല്ലാവർക്കും വിഷിങ് യു ഓൾ ദ ബെസ്റ്റ്. അപ്പം എല്ലാവർക്കും ഇന്നത്തെ സെഷൻ മനസ്സിലായിട്ടുണ്ടാവും എന്ന് വിചാരിക്കുന്നു. ഇനിയും ഇതുപോലുള്ള ലൈവ് സെഷനുകളിൽ നമുക്ക് വീണ്ടും കണ്ടുമുട്ടും വരെ ഏവർക്കും നന്ദി. ഗുഡ് നൈറ്റ്. ബൈ ബൈ. താങ്ക് യു. അവസാനമായിട്ട് ഇതിനകത്ത് ഏറ്റവും കൂടുതൽ ഉത്തരം പറഞ്ഞ വിദ്യാർത്ഥി എനിക്ക് തോന്നുന്നു റിനയാണെന്ന് തോന്നുന്നു. റിനയ്ക്കുള്ള സമ്മാനം അത് ഡോപ്പ നിങ്ങൾക്ക് വേണ്ടി നൽകുന്നതാണ്. ഓക്കെ, താങ്ക് യു.